All right, so on the front here, we're going to list out how you find all of the characteristics. And you can do this in whatever order you want, but I'm going to go through it in kind of the order I think makes logically the most sense. And that would be that you do the domain first. So you're going to exclude, and it sounds rude. It's like, who are we excluding? You're going to exclude where the denominator, and can I abbreviate denominator DEN and numerator NUM? Is that okay? Okay. You're going to exclude where the denominator equals 0. You're not allowed to divide by 0. I call these numbers the troublemakers. They're causing trouble. Kick them out. Like, we're excluding them. It's everybody is invited to the domain party except those troublemakers. Okay, I try to sound silly about it because then you'll remember, right? But you kick out the troublemakers. Now, once you've kicked out the troublemakers, there's 2 career paths that are available to them now that they've been kicked out. They can either become a whole or a vertical asymptote. Now, I know there's a hole right next to the word whole, but maybe put stars next to those 2, whole and vertical asymptote. Once you kick your numbers out of the domain, those are the 2 things that they can become. So how do you know which one it became? The wholes come from factors that cancel out. So if it canceled, then it's going to be a whole. And if it didn't cancel, then it's the vertical asymptote. And when you write a vertical asymptote, it needs to be x equals whatever. You can't just put that number. It's a vertical line. So it's x equals whatever. Do you remember Hoy Vux, like that acronym to remember that? X equals. Anyway, vertical is x equals. So I usually do those 3 things first. Domain, and then whatever you've kicked out of the domain, it can become one of those 2 things. Okay? Then we're going to go down here to horizontal or slant asymptote. All of this is review from last year, except for the slant asymptote. That's the new thing. And this is the tough characteristic because you have to do a comparison. If your numerator degree, and that's the highest power, I usually say that's who's in charge here. That's like I would like to speak to the manager. It's like the biggest exponent. If your numerator degree is smaller than the denominator degree, then it is automatically y equals 0. And here's how my brain does that. If the denominator keeps on getting bigger and bigger, bless you, you get a situation like this: 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, until you get out, and it's difficult to think about infinity, but until you get out to like 1 trillionth. And how big is 1 trillionth? Like, if I offered you 1 trillionth of a piece of cake, you would be like, gee, thanks, Miss Cole, because that is. And so that's why it levels off at 0. Okay. Or you can just memorize it, but that's why it's true. All right. If your numerator degree equals the denominator degree, and I think this is everybody's favorite version of it, when they're equal, as a tiebreaker, you use the leading coefficients, which is just the numbers out front. So I think everyone likes that version because it's like, oh, just those numbers that are right there. Cool. Like, just copy those. Fine. And that you did last year in Algebra 2. The third version is the new thing. So what's the one we didn't do yet? We did smaller, we did equal, but if your numerator degree is bigger than the denominator degree, last year you just wrote none. You wrote that there wasn't a horizontal asymptote. There is an asymptote. It's just called a slant asymptote, which is exactly what it sounds like. And I just go like this when we're talking about it. The graph levels off slant-wise. That's cool. Isn't that cool? It's neat, guys. It's going to level off like that or like that. Okay. The reason you didn't learn about it last year is because you're going to use synthetic division to find it. And you hadn't learned synthetic division last year, so that's why you didn't go over that. So that's the one new thing that we're doing. So again, to recap what we did so far, I usually do the domain first. Whatever you've kicked out of the domain will become one of these 2 things, a whole or a vertical asymptote. Then get the horizontal or slant asymptote. So you've got all those asymptotes in there, like all the invisible lines. And then you want to plot some points. So I would go back and get the intercepts. So your x-intercept, you're going to set your equation equal to 0. You just take the whole thing, set it equal to 0, and you will get something, comma 0. So an x-intercept would be like 2, 0, or -3, 0, or whatever. How do you get a y-intercept? Yeah. Good. Plug in 0 for x. Perfect. Well said. And so that point would be 0, comma something. And at that point, you can connect the dots or the holes and like level off at the asymptotes and like draw in the rest of the graph. So after that, what are the 3 things we have left? Range, increasing, decreasing, and end behavior. It really doesn't matter what order you do those in. Once you have the graph, you can kind of look at it and do that in whatever order. For the range, you're going to exclude the y value of the hole. You're excluding the hole because it's literally missing. Why is it the y part of it though? Like, why would you leave out the y part? It's just range. Domain is x, range is y. So you're going to exclude the y value of the hole and the horizontal asymptote. And that's because if it levels off at that horizontal asymptote, then it won't touch that value. So you've got to leave that out. And then increasing and decreasing, you read it left to right. So you're going to copy over the domain. It's always the domain. It's never going to be the range because you read left to right and that's x values. I would never take off for spelling, just write ASYM. But this is how you spell it. There's a sign like P in the middle. Asymptote. All right, and then your end behavior, it's either going to be the horizontal asymptote, if there is one, because if that's where it levels off left to right, that's where it's going to head, all right? So it's the horizontal asymptote, or if it's a slant asymptote, it would be positive or negative infinity because it's going to go up or down. So horizontal asymptote or negative infinity or positive infinity. It can't be any other thing. It's either going to level off or go up or down. So we're just going to see how many of these we can get through. And I don't want to do too many because I want to save some for next time. How many do I have on here? 10. We'll see if maybe we can do 5 of them or even 4. If we even get through 4, I'm happy. All right. They sometimes take a while to start out with because there's a lot going on here. Yeah, because it either goes down or up, so it would be negative or positive infinity. So the first thing you would want to do is factor. I'm going to start out with the easiest example, right? Like I'm not going to start with a really hard one. So nothing here factors. We're going to do the domain first. Who is our troublemaker that we have to kick out? Not invited to the domain party. Not 2. Why is it -2? It makes it divide by 0, and you cannot divide by 0. So do you remember how to leave out -2? You want everybody invited except -2. I'll give you a hint. It starts with a parenthesis. Negative infinity, good. 2, not 2, but -2, parenthesis, because you want to exclude it. U. Good. What this is saying is you want everything to the left of -2, everything to the right of -2, but not -2. The most common mistake I get on that is people put brackets. Brackets indicate you want the number. We don't want the number. You have to use parentheses, leave it out. All right, now we've kicked out -2. -2 can either become a hole or a vertical asymptote. It can't be both. So which one do you think -2 has become? Why is it the vertical asymptote? Nothing cancels out. If something cancels, it'll be the hole, but nothing cancels, so we don't get that. And x equals -2 is your vertical asymptote. So you want to kind of do those 3 things together, the domain, the whole and the vertical asymptote, because whatever number you kicked out, it's going to be one or the other of those. And then you can go ahead and dot that in. So x equals -2 over here on the graph. I try to like find a characteristic and then draw it on the graph, find another characteristic, draw it on the graph. So you're not trying to do everything all at once, like do it one thing at a time. Then I would do the other asymptote. Now this one, I made it an easier example, but it's like, do you notice how everything, like sometimes it'll get so easy that it's actually harder because it's like, there's nothing there. So in the numerator, what you really have is an x to the nothing, if you want to think of it that way. So when you compare these powers, this one's 0, and what's this one? 1. So 0 is smaller than 1. And so it's horizontal and it's automatically going to be 0. If you don't have that memorized yet, congratulations, you're a normal person. I like just went over it. Okay. But the numerator is smaller than the denominator, so it's automatically 0. And then you can go ahead and dot that in. It's hard to see because it's on the axis, but it'll level off at 0. So everything we have drawn on the graph so far is invisible. It would sure be great if we had like actual points. So that's why I go back and do the intercepts. So let's do x-intercept first. You're going to take the whole equation and set it equal to 0. And that's just a margin problem. You can just do that off to the side. Just take the whole thing, set it equal to 0. And then, yeah, you got to do some algebra. What would you do to start solving that? Yeah, good. If you multiply that over, though, and you end up with 3 equals 0, which doesn't make any sense. If you get 3 to equal 0, please let me know. You've broken the space-time continuum, all right? So there just aren't any. What else about the graph indicates that that would be none? There's an asymptote. Good, perfect. We're making connections. All right, y-intercept, we're going to plug in 0, which is easier. Just plug in 0, see what you get. So if you plug in 0 for x, 3/2, good. Now, when you go to put that point on your graph, though, you have to know where 3/2 is. So what is 3/2 as a decimal? Well, it's close, 1.5. Yeah, just 1.5. So somewhere in between 1 and 2 is good. And then you can connect it. And then you're like, connect what, Miss Cole? There's like nothing there. Okay, well, you have the asymptotes to level off at, and you have to go through that point. So this arm of the graph is going to do that, and then you're going to have this arm of the graph down here. You can always make a table. What do I get if I plug in this? What if I get if I plug in that? It's more work, but if you're like, hey, I just need to fall back on that, you can always plug in more numbers. Now, once you get there, it really doesn't matter what order you do the rest of this in, because you have the picture to look at. So I'm just going to do it in the order it's written. So range, if we sweep downwards to upwards, who is getting kicked out of the range party? 0 is not invited to the range party. So you're going to do everything smaller than 0, union everything bigger than 0. You want everybody except 0. Because it levels off there, but it won't ever touch. And then increasing, decreasing, we're going to read left to right. So just watch, I'll point to it. What is the graph doing? Decreasing. And then still over here, decreasing. So your increasing is none. And because we went left to right, what answer do you copy over? Because the answer is already one of these. We're just going to copy it. Domain, because it's left to right. So just literally copy that answer. And if your domain is wrong, but you copy it over here, I give you credit for the decreasing. Bless you. Bless. So you could have nonsense written here, but if you copy that over, I'll give you credit for the decreasing because you knew that it was decreasing. All right, and then go ahead and set up your end behaviors. Limit x goes to -infinity for the function, limit x goes to +infinity for the function. The only choices for what it can do is level off or go up or down. This one levels off. And what was our horizontal asymptote? 0. So these are both going to be 0. Will it ever actually touch 0? No, it's behavior. That seemed like it went smoothly. How are we doing? Go ahead. Yep. And that's what I was saying. If that bothers you, you can make an XY table. What do I get if I plug in this? What do I get if I plug in that? You can always do that, but it's not necessary. These graphs are complicated, but they can be easy to graph because you don't need a whole lot. Like once you have these invisible fences in there, it has no choice but to coast along them. So you're kind of fenced in. You don't really have a lot of options. But if you feel like you want to do this, you can always do that. If you're like, I just feel more comfortable with more points, you can do that. All right. This one is slightly more complicated. We're going to have to actually factor it. So, hey guys, how would you factor the numerator? There we go. We got there. I knew what you were trying to say too. Yeah, sometimes like the brain to mouth connection is like a little, if you're awake and talking to me, I'm thrilled. So, all right. And then the denominator, you're going to have to draw your two parentheses, x and x. And then what do you think? Good. -3 and +1 will give you -2 in the middle. These problems can be kind of helpful because if you get something like that, you can be pretty sure something's going to cancel. So you can like, you know, hey, I can sort of figure it out. Now, don't cancel out until you do the domain. I'm going to say that again. Yeah, everyone's bringing up the butterfly thing. So if you cancel before you're supposed to, they would kill a butterfly? Yeah. It sounds like we're going to have to color butterflies because everybody really likes that. Do you guys know what they're talking about? I'm going to have to go get some butterflies. All right. Well, anyway, I'm going to say it again. Don't cancel out until you do the domain because you will miss one of the troublemakers. There are two troublemakers in this graph. Who are the two troublemakers? 3 and -1. Now, it does matter what order you do them in because it has to be smallest to biggest. So which one's the smaller one? Good. Okay, so it's going to be -∞ to -1. They will make the denominator 0, and you are not allowed to divide by 0. So 3 is one of them, and -1 is the other one. So union -1 to 3, union 3 to infinity. So it keeps getting longer the more troublemakers you have because you have to keep on skipping over more and more numbers. In theory, now I won't give you more than 2, but in theory, if there was a third troublemaker, you would have another union in there. Do you get what I'm saying? Like you would just keep hopping over, thank you for heads nodding, like more numbers, you just keep leaving them all out. But it has to go smallest to biggest. So you have to do the -1 first, then the 3. All right, then you are allowed to cancel. So listen, your -1 and your 3 can become either a whole or a vertical asymptote. So I will tell you, one of them is the whole and one of them is the vertical asymptote. Which one is the whole?
Oh, I know. I mean 3.
3 is going to be the whole. So hold on for a second because we'll have to come back to that. Why is 3 the whole? Because it canceled. -1 is the vertical asymptote. And you can dot that in on your graph. And again, usually as soon as I find something, I go put it on the grid. It's the one that didn't cancel. So 3 canceled, so it's the whole. If it cancels, it's the whole. If it doesn't cancel, it's the vertical asymptote. Cancels is the whole, doesn't cancel is the vertical asymptote. So how do you get the other part of the whole? What would you need to do with 3?
Plug in 0.
Well, you're going to plug in 3. Okay, so guys, look, here's what we've got left. We're gonna plug in 3, ready? 3 plus 3, 6. And then 3 plus 1 is 4. Good. Which is 1.5. So you're gonna put a hole, which is an open circle, at that coordinate. 3, 1.5, which would be like right about there. Now, listen, when you go to connect everything, you have to connect to the hole. I get this, well, it stopped happening since I've started teasing people, okay? But people will put like the hole right here, and then they'll draw their graph like this. And I'm like, what are you doing? And usually I'll turn it into the sun or something and then write like LOL and tease them. Because if I tease you a little bit, you won't do it. You can't have a hole floating out in space. It has to connect to the graph. Okay, it has to be the hole on the graph. All right, so anyway, rant over. All right, let's go do the other asymptote. You're gonna compare your powers. So hey guys, look, this one's squared. They're the same. This one's squared. That means you use the coefficients. Now that's kind of tricky because they're not written, but both of them are 1, and 1 over 1 is 1. So you get y equals 1. Now I couldn't really show you this on the last problem because it was on 0, it was on the axis. If you want to dot it the whole way through, you can, but my suggestion is only put it at the edges. Only put it at the edges because it's really just the ends. And here's why I bring that up. Let me get another sticky note. Sometimes really weird stuff can happen with these graphs where it'll level off over here and then actually go through it in the middle and then level off over there. And if you've dotted it the whole way through, people get upset because they're like, the graph went through the asymptote. And I'm like, it's okay. So I just put them at the edges is my suggestion. Or you can put it the whole way through, but if the graph goes through it, no crying, okay? Now, everything we have on here is invisible. So it'd be sure great if we like had some actual points. All right, so let's go back and get the intercepts. So for the x-intercept, you're going to take this and set it equal to 0. So what we've got left here. So I'm just margin problem. X plus 3. Oh, you're already there. Let me get everybody else there. Hold on. You take the whole thing, set it equal to 0, and then you do algebra. What would you do first? Good. And if you multiply that over, still 0. So it would be -3. So -3 comma 0. And again, then I would immediately put that on your graph. As soon as you find something, go put it on the graph. So you're doing it one at a time. Because if you make your whole list of characteristics, then you go and try and put it all on the grid, it's going to feel overwhelming. Do it one at a time. Because these are a lot. This is one of the harder units. It's complicated. All right, how do you get the y-intercepts? Now, plug in 0. So 0 plus 3 is 3, 0 plus 1, 1. So 3 over 1, 3. And then go put that on your grid. And once you get there, you're just going to connect everything. Just make sure you go through all the points and the hole like you're supposed to. Like just make it connect. And then you level off at the asymptotes. I kind of missed that one. Let me redraw that. Are we complaining? I'm not grading your art skills. Oh, okay. Well, that's a personal thing. Now, once you get that drawn, it really doesn't matter what order you do the rest of the stuff in, because after you have a picture, you can kind of just look at it. Let's do the range next. There are 2 troublemakers getting kicked out of the range. Can anyone give me one of them? 1, because that's where it's leveling off. And, well, 1.5, 3 halves. Okay. So as you sweep downwards to upwards, you're gonna leave out 1 and then 1.5 or 3/2. So negative infinity to 1, union 1 to 3/2, union 3/2 to infinity. It doesn't become more difficult, is my pep talk. It just becomes longer. You have to keep on unioning on for each number you're leaving out. You'll be okay. I'm not going to give you more than 2. All right, increasing, decreasing. As you read left to right, what is the graph doing? All right, so increasing is none. And what do you copy over? Domain. Just whatever it says for domain, copy it over. Because it decreases all the time, which means for the entire domain. And then go ahead and set up the end behaviors. And the ends can either level off or go up or down. Those are the choices. So since this one levels off, where does it level off at? Like what number? 1. And so these are both going to be 1, but the follow-up question is always, will it ever equal 1? No, it is behavior.